So you have two concurrent processes running at almost the exact same time, like only nanoseconds apart. But both of them are trying to update the same variable counter. The first process reads the current value of the counters, then increments the value and store it back in memory. At the same time, the second process also does the exact same thing. It reads the same old value, increments it, and writes it back. So if the current value is 1 and each of the process and counter increment it by 1, now the counters will be wrong because it should be 3, but the value stored is only 2. Why does this happen? This problem is called erase conditions. It happens when multiple executions access and modify shared data without proper synchronizations. This happens a lot in distributed system. So how do we prevent it? One of the common solutions is to use a locking mechanism. There are many types of locks such as semaphores, read-write locks, and mutexes. In this case, we will focus on mutual exclusions or mutex. Let's say we have thousands of executions and want to update the same variable or resource in the memory. Mutex will ensure that only one of them can enter the critical sections at a time, no matter how small the time difference is. When the first process arrives, it will acquire a lock, and then other process must wait until the lock is released. This guarantees data consistency for shared memory. However, locking has also a drawbacks. We must keep the lock sections as small as possible. Why? Because locking too much code can create an overhead, and under high traffic, this can become a bottleneck because other executions will force it to wait longer. We also must always ensure that every lock is properly released. If one error occurs while the process is locked, we need to make sure it released under any of the error scenario, because if not, the lock will never be released and other execution might end up waiting forever, or it's called stale lock. That's it, the trade-off. Thank you for watching.